Hi there and welcome again to the channel. In this video, we want to do multiplication of complex numbers. If you watched our previous video, we were doing addition and subtraction of complex numbers. You can check on it. It's there on our channel. So we want to multiply Z1, which is 3 plus 4i, by Z2, which is equal to 2 minus 6i. So our first task is to find Z1 multiplied by Z2. Then the second task is to find the modulus of the resulting complex number. And thirdly, and finally, we want to find the argument of the resulting complex number of multiplying Z1 and Z2. So why don't we just start cracking? So Z1 is equal to 3 plus 4i. And our Z2 is equal to 2 minus 6i. Let me just put them in brackets there. So we are going to do it slowly. Our Z1 multiplied by Z2 is equal to, we put the brackets, 3 plus 4i as usual. And this one comes here, 2 minus 6i. Right. Just like we do with algebraic expression, we multiply 3 by 2 to get a 6. And then 3 multiplied by minus 6i is equal to minus 18i. Okay, so we are done with this and that. Now we want to multiply this and that. So 4i multiplied by 2 will give us a plus 8i. Right? A 4i multiplied by a minus 6i. Here's what we have to remember. Let's write it like this. I'll do a little calculation over here. So it's like 4i, that's what we want to multiply, multiplied by 6i. Okay, so I can also write this as 4 multiplied by minus 6 multiplied by this I multiplied by this other I. Can you see what's going on here? The 6 is negative, so there it is. And then there's this 4 here. So the 6 and the minus 6 and the 4 are multiplying each other. We'll get what we get there. And then we have the I multiplying the I. So let's deal with the real part here. 4 times minus 6 is 24. But what is I multiplied by I? Remember, I is equal to the square root of minus 1. So I times I is equal to the root of minus 1 multiplied by the root of minus 1, which is just equal to minus 1. So that's what we have to know always, that when I multiplies itself, I squared is always equal to minus 1. So here we have a minus 24 multiplied by a minus 1 resulting from this and that multiplying itself. So that becomes now times minus 1 and we get a 24. It's just a side calculation I was carrying out there to remind of ourselves what's going on here, because it's not a fairly simple multiplication there. We do have an I, so we have to be a little bit more careful. So remember we got a positive 24. So we can write here 4i times minus 6i gives us a 24. Okay, so let's clear this. We really don't need this now. Okay, so now what's left is to simplify. Let's deal with the real part. There's a 6 here and a 24 there. Adding together, they give us a 30. And then a minus 18i plus an 8i gives us a minus 10i. That is the answer. So Z1 multiplied by Z2 is equal to 30 minus 10i. Okay, maybe we should write it down somewhere here. So z1, z2 is equal to 30 minus 10i. Okay, all right. So we can clear this. We are done with the multiplication because we want to go on to this part here, the modulus. Now that we have the product z1, z2, we want to find the modulus of that complex number, which of course is that one there. So what do we get, right? So we want z1, z2 modulus, and it's equal to the square root of 30 squared plus the square root of minus 10 squared, which is equal to 30 squared is 900 and minus 10 squared is 100. So this finally equals square root of 1000. Square root of 1000 is 100 times 10, isn't it? 1000 is 100 times 10. So this will be equal to, when we simplify the z, it becomes 10 root of 10. Because remember, we are saying this is equal to root of 100 multiplied by root of 10. So root of 100 is 10, and we're left with there. So this is the modulus of z1 multiplied by z2. Okay, right, let's go on to the next stage where we need to find argz. Perhaps, just in case someone might be wondering where we got this. Sorry about that, because I'm a little bit worried about somebody who might not understand where we got all this thing here. So let's just go back to our argand diagram. Supposing we do have a complex number, which is, let's say, z is equal to x plus iy. Remember, we can plot this thing on an argand diagram where, of course, this is your real axis, this is your imaginary axis. Okay, so which is y. So our complex number will be somewhere here. This is where z is with coordinates. This point representing the complex number with coordinates xy. So this, of course, the length of this line would be equal to the modulus of the complex number, which is modulus of z. So, but we know that from here to there, it's y, and from there to there, it's x. So, what is this line? From elementary coordinate geometry, we know that if this is r, we know that r is equal to the root of, from the right angle triangle there, r is equal to x squared plus y squared. This is where we got our 30 squared plus our y squared. It's just elementary coordinate geometry. Now, this little diagram is going to help us again in finding our argz, because remember, I hope the little triangle is visible from there. Now, supposing this angle is theta, okay, again from the same triangle, we know that argz, this complex number here, would of course be equal to the angle whose tangent is y over x. Okay, right. With this in mind, what is our complex number? z1 multiplied by z2, and it's 30 minus 10. In other words, our x is 30, our y is minus 10. So therefore, arg, we can now write here, perhaps I should clear the board so that everything is clear, is separated from everything else. Now that we know where we got this from, and how we can calculate our arg z, we can now say arg z1, z2 is equal to the angle, in other words, arctan, the angle whose tangent is minus 10 over 30, which of course would simplify to arctan minus 1 over 3. Okay? And of course, we know that if it's of this thing, it's going to look like our y is negative, so we are down here somewhere with y, but our x is positive, so the complex number is here somewhere, where y is negative, x is positive, and our theta is this angle here. Okay, our theta is this angle here, so it's a negative angle whose tangent is minus 1 over 3. It's important to get this, the order right, because this tells us that y is negative and x is positive, because if you mix it up, you can put it over here somewhere or whatever it is. So it's important to know that here my y is negative, but my x is positive, so I will locate my theta here. If my x and my y were both negative, I would be here somewhere where x is negative, y is also negative. If x was negative, y was positive, then I would be here because my x is negative here, but my y is positive. So it's important to look carefully at the signs of these two components of the complex number. So that's all we can say as far as multiplication of complex numbers is concerned. Remember, you multiply as if you were just multiplying an ordinary algebraic expression, except that when you come here to multiplying the i's together, just remember I squared is equal to minus 1. We can go on and say, what is I cubed? I cubed is equal to I multiplied by I squared, isn't it? So, but we discovered I squared is equal to minus 1, so this becomes minus I. What is I to the power 4? It will be I squared times I squared, which is minus 1 times minus 1, which is a positive 1. So, but starting from I squared is equal to minus 1, you can find any power of I. So till we see you in the next video where we are dealing with division of complex numbers, bye-bye and take care.